our presenters tonight are from Cielo Networks. Their background is in RF IP connections, I believe. And we have Brian, I don't know where they are on your screen, but Brian Wright is at the top, in the top row with me, and Lilly is right next to him. So I do not know if you guys have a slideshow.
Yeah, we do.
Okay, I've released the share screen, so
Okay,
whoever has it loaded up, you should be able to share your screen.
Share, let's see, share 3. Do you see it?
I can see it.
Oh, all right, good.
Yep, got it.
Okay, so we can take off now. Can anybody hear me?
Yeah,
Yes.
Go ahead, Sale.
Yes, you may begin.
Eric, thank you so much for having us, and we appreciate you letting us come back. We were there about a little bit over 3 years ago, and we're at the CBS studios at the time with Tom Shedlick, and it was good meeting everybody in person. And I know there's some new guys here and some ones we didn't meet in the past, so we look forward to meeting you hopefully in person in the future. And we're going to get right into the meat of the discussion. Brian's going to talk about the microwave options for the broadcast industry, and then I'll talk a little bit about Cielo Networks at the back end of the presentation. And feel free to, we'll have questions at the end, but feel free to interject anytime through that. Brian, I'll go ahead and turn it over to you now.
Okay, thanks. I appreciate everyone's time this evening. I'm coming to you live from Dallas, Texas in the heat. So we're gonna discuss licensed microwave part 101, which is where we offer products in that common carrier license bands. We'll review the part 74 and 101 frequency bands, and then the new rules for broadcasters, which they're not so new anymore. They were new in 2017. So time has passed. You know, why you want to use microwave, our technology, how do you get ready for a link, plan for a link, the licensing process, the costs, reliability, management, and then just a quick overview of Cielo Networks. If you have any questions during the process, please feel free to jump in, and or we can wait till the end to answer any questions you might have as well. So in the past, you guys operate, and you still do, operate in what's called the Part 74 band that's used by broadcasters for, your broadcast signals for all your TV. And you operated from the 900 megahertz band, low capacity, up to 13 gigahertz to get that signal by microwave to your transmitter sites. Part 101, which is what I've been involved with since 2000, is for fixed point-to-point microwave. It was used by everyone other than the broadcasters. In the early days, we were TDM with the legacy networks, but now everything is Ethernet and just providing higher and higher capacity with newer technologies. We're able to go over a gigabit per second based on channel sizes if you're able to get them. So it's all based on channel size and modulation for what your capacity is. Our bands that, Part 101 bands that you can operate in are 6, 11, 18, and 23. Again, it's the lower frequencies, the longer you can go, and the higher frequencies, the shorter you can go, but there's more channels available for it. And to go through this Part 101 licensing process is a very straightforward process, working with frequency coordinators to get your license. And then once you have your license, you have it for, it's good for 10 years, and then it's just a simple renewal to keep that license active. And with that, it's federally protected against interference. Someone else can't come online and get a new link, and that would interfere against you. And that's compared to unlicensed, which we'll dive into a little bit in a future slide about the licensed versus unlicensed. So in 2011, the FCC defined new rules which allowed us, the common carriers, to use the 713 gigahertz bands that was used by the broadcast industry. But for common carriers, there's a lot of exclusion zones, and so it's not used by common carriers. We haven't sold any products for this band, so I don't think anyone is using it for a point-to-point microwave. It's just as easy to go to the 611, 18, or 23 gigahertz. But for you, you had, now you were not forced to stay in Part 74. You now have the option to use the Part 101, which gives you a lot more flexibility as to what you can do with providing data services or getting your video services or whatever type of services you want to your transmitter site or to anywhere. You're not locked into just using those Part 74. So you got the final mile to your studio to transmitter site. You could use it for primary or backup for your broadcast links using these 6 to 23 gigahertz. And all these channels are full duplex. So if I'm talking about 100 megabits there and back, 1 gig there and back. So these are all full duplex Ethernet type interfaces. You plug in your Ethernet, and that's the throughput you're gonna get. So it's not, you don't need to use this just for that final mile, quote unquote final mile, which is for your video traffic. You can also use it for providing your remote management at the site, cameras, door alarms, etc. You could do remote file storage, backups there. So a lot of options that you can have there, or just simply having access back to the office when you're out at the transmitter site. And of course, there's other applications where you just connect your remote offices together with your own private network versus leasing services from the carriers, especially if you have a lot of traffic going back and forth and you're paying a lot on a monthly basis to the carriers. So why use microwave? Well, you can connect via dark fiber or the public internet, but there's some benefits, clear benefits to the point-to-point microwave. And for fiber, the biggest issue with fiber has high capacity, but they're also susceptible to the backhoe fade. And when that backhoe cuts into the fiber, you're down until they can get things patched up and repaired. And then if you're using the public internet, you're just subject to that shared resource and the demands that go up and down. And then also your security, you're on there with everyone else who's trying to hack away at whatever you have connected to the internet. So with the microwave link, this is your own private network. You're not sharing the bandwidth. It's your link between the two sites that you have connected together via Ethernet. And although you have an initial cost with putting this in, the ongoing operational costs can make it very attractive. So you can combine, we have customers that use microwave as backup to their fiber connections. So you can use this to provide even higher system reliability to your sites. Just use it as a backup, just in case you've had issues in the past with your connectivity, landline connectivity to the sites. One of the advantages of microwave and putting in point-to-point links is your time to market. You can be connected in days having those sites connected versus putting in fiber and waiting for right-of-ways to be established. That can take years to get your own fiber lines in place. And then finally, if latency is critical, microwave is the best solution, because with fiber, you'll never get a straight line access versus microwave, which is point to point. It's going to be the shortest distance between those two sites. So your path distance is less, and latency is all a function of path distance. And microwave is even faster, 5.3 microseconds per mile when the signal's passing on going via RF versus fiber. Fiber, signal travels through fiber, you're at 2/3 the speed of light, so you're at 7.9 microseconds per mile. Plus, instead of going, your line of sight's 2 miles and you're going 5 miles, well, there's some added latency just based on the fiber not being a straight line to your site. So how far can microwave go? Well, it's all a function of line of sight. So the line of sight that you have in place, that's what you will get. The higher you can go on your tower, the better. We have in sales back neighborhood, we got a customer's getting ready to put in a 40-mile hop. So again, it's just a function of being up high enough on the tower so you could go farther, and that's going to operate at 6 gigahertz, that 40-mile hop. So the 23 gigahertz, the higher the frequency, the less you can go. Typically 23 gigs less than 5 miles, 18 gig 5 to 10, and 11, and then it's 10 to 15, and 6 greater than 15 miles. With the higher frequencies, you're dealing with fading. Your fading conditions are based on rain primarily, versus the lower frequencies 6 and 11, which are more of a multi-path issue. So what you do, you can engineer it properly to increase that reliability, the availability, by adding space diversity with your diverse antennas, your main and diverse antennas. So we work with customers to provide path engineering. We use path loss. We calculate, again, you calculate just based on terrain how high we need to go on the tower, and then what's the best solution, what's the best frequency band, what size antenna, etc., that we need to get you the availability that you require for the hop. So in the licensed microwave world, the primary, there's really 3 different types of architectures. There is the split mount architecture, which is where Cielo Networks started. And that's where we have a indoor unit mounted indoors with your switches and other devices, and then your outdoor unit, which is directly connected to the back of the antenna or located next to the antenna, and then we use flex twist to the back of that. The advantage is that you can use coaxial cable to run up the tower between the indoor unit and the outdoor unit, and this reduces the cost of the install by just running that single low-cost coaxial cable. Our indoor units, most everything's Ethernet now, but we do support legacy networks. We deal with customers that still have T1s and are not ready to shift there, so we do have T1 interfaces available, and most of the licensed microwave vendors do have it. They can so the outdoor unit, it all looks the same, but there's different ones for the different frequencies, 6, 11, 18, or 23 gigahertz. Between the indoor units, the same across all the bands. It uses a common IF band, 140 and 350 megahertz, up the coaxial cable to the ODU. But there's no, power is also supplied via that coax cable, so it's just that single coax cable. So when you put this in, you're going to have to climb the tower to put up the antenna and the ODU, unless you're lucky enough to be on a rooftop there. The next architecture is an all-indoor architecture. This is where you mount your radios, your indoor unit indoors, so that if you have any issues with a site, or you're in a very cold weather site where the tower freezes over and you can't have guys climbing the towers in the middle of winter, then an all-indoor architecture may be a better solution. With this, the radio is mounted indoors, and then you run elliptical waveguide up the tower to the antenna. So with the longer waveguide to the antenna, you're actually going out 6 and 11 gigahertz up the tower to the antenna. So you have losses associated with that elliptical waveguide. Again, with path engineering, we define, what is still your availability. We consider those losses. But we do offer higher power radios. These look similar to the split mount where it goes to the back of the antenna, but we offer higher power radios for these applications where the customer's wanting to mount their radios indoors. The example of this is a customer in Puerto Rico that mounted theirs indoors and is operating in a hot standby protection. So you see the two radio links connected to what we call a coupler, and then the elliptical waveguide out to it up to the antenna. One of the newer technologies that's really taking off is the all-outdoor solution. These are all Ethernet-based solutions, but they have an advantage in the fact that they can support higher capacity. With these units, everything, there's no indoor unit, outdoor unit. There's just the radio, there's just the transceiver module with a built-in modem that's mounted to the back of the antennas or located adjacent to the antennas. So everything's up on the tower. But with this solution, we can go with much wider channels. And over the years, FCC has added wider channels to support higher throughput for customers. So all you have indoors or mounted to the tower at the base of it is you have a power over Ethernet device to connect your Ethernet data, and then 48 volts DC power, and run an Ethernet cable up the tower. We have some customers, you know, if you have to go over 300 feet, then we have customers that go to a fiber and 2-wire cables type solution. Or if they want a little better isolation, then they use, you know, worried about lightning surges, et cetera, on that Ethernet cable, they go with a fiber solution, a fiber connection for their data. This is also available at 6 to 23 gigahertz. There is also E-band, which is something that we've recently introduced. E-band's 60 to 80 gigahertz, 60 gigahertz unlicensed, 80 gigahertz is slightly, kind of lightly licensed. Everyone kind of manages it with each other. But these are for very short distances, you know, across a campus, for example, but they can provide very high capacity with the wider channels that they offer. But that's not, the E-band's not part of the, under Part 101. What's your radio link capacity? Well, your radio link capacity is a function of channel size and modulation. So the wider the channel, in the most channel sizes, they start out at 10 megahertz, but most customers are doing 30 to 80 megahertz channel sizes. So it's a function of the channel size, which depends on the frequency band that you're operating at, as well as the modulation. The higher the modulation, the more throughput that you can get through. But the higher the modulation, your receiver sensitivity decreases. So there's a trade-off in regards to how far your link can go. But we are now able to support with our AON product 4096 QAM. You know, when I started out in this, we were at 128 QAM. Now we're at 4096 QAM. So we can get a lot more throughput across that radio link with these higher modulation capabilities that can be offered. So we can go, you know, when we have this all outdoor gear, we can support over 2 gigabits per second, because in one of those single radio units that you saw on a previous page, now we got another picture of it, we can do up to 4 channels out of that to the back of the single antenna. So you can get a lot of throughput across that radio link. Antennas, you know, the antennas that we offer, customers have, is, you know, you can do a direct mount where that radio connects to the back of the antenna, makes the installation very simple and straightforward. You minimize points where you get water ingress by minimizing your connections. You can go much larger antennas for long hops. We have, you know, that 40-mile hop, he's going 8 foot on his main antenna and 6 foot on his diverse antenna. And we have customers that have done up to 12-foot antennas. I think the largest I've seen is a 15-foot, but that's really big antenna for really long hops, usually across from island to island, those 15-foot antennas. They do have antennas for high wind environments, extreme environments. So again, there's different options, different solutions based on where you're going to deploy this point-to-point link. And some customers, they have existing antennas in place. They're replacing old gear, and we can many times use that existing antenna. So they don't, you know, you don't have to install a new 8-foot antenna, which can be very costly when you're installing, having to take out the old one and install a new one. You can save a lot of money in that installation by using what's in place. So when we're planning a path, we work with customers, we find out what the coordinates are so we can define, is there line of sight between the sites, between the two sites, so that you can put in the microwave link base, or if it's something new, well, how tall of a tower are you going to need? So we use a tool called Path Loss, which allows us to download terrain data for every link here in the U.S. Market. And we work with customers to define that, the line of sight, as well as what is the best frequency and channel size, etc., to use. With Google Earth, it's made it a lot easier. You can also do a lot of this with Google Earth. You can check for building obstructions, but you also need to be considering, future building plans. I know that the link for CBS Radio up there in DC, he had the one link in, but then he had to move it because there's a lot of new buildings going up right around where they had our product located on the top of their building. And we also have this Fresnel zone. We have, so you have line of sight with the center beam, but there's the Fresnel zone, which you have to clear. The lower the frequency, the larger the Fresnel zone. But again, this path engineering tools that we use and consider the Fresnel zone, and make sure that you have Fresnel zone clearance, so you have full clearance across the radio link. So when you're doing this, you're planning, well, how much capacity? Because the capacity that you require between these two sites partly define, well, what size antenna do I need? What frequency band do I need? What channel size do I need? So you need to consider what you need now, but you need to be planning for the future. How much do you expect your data requirements to increase over the years? So that if you are increasing capacity, you can start off by purchasing a license for 150 meg capacity. Most customers offer, lower capacity now, and then with an upgrade key, you can increase the capacity of the radio link of the units without having to redo any of your licensing. You can do this all from your home offices, as we're having to do now. So you can make it very easy to upgrade the capacity of your system. So that's all part of it. With that antenna, we also work with customers with the antenna size, because, especially if we start getting large antennas, can that antenna be supported by the tower that you're going to operate on? If you're on a rooftop, can you get it up the service elevator, or are you going to have to get someone to lift it up over the side of it? And then, are there any tower loading restrictions as well too? So all things to consider with putting up these point-to-point hops. When we do our path planning, we include adaptive modulation so that we know that the availability at the highest modulation is, it may not be 5 nines, it may be a little bit less than 5 nines, but now with adaptive modulation, with the system, as fading conditions occur, we'll reduce the modulation on the system automatically, being hitless. When we reduce the modulation, while the throughput decreases, we're still able to pass data across the radio link during these fade conditions. So we drop modulation, we can, as the signal fades, we can just keep operating at the lower modulation due to improved receiver sensitivity until the fading condition goes away, and then we're able to increase the modulation up to your maximum that you define. So with the advent of ACM, adaptive modulation, you don't just fall off a cliff all of a sudden. You have lower throughput, but you're still passing data. And with, in your type of networks, you can prioritize the traffic so that even under fading conditions where the traffic throughputs decrease, you prioritize your traffic so that the most important traffic is still able to get through to the remote side. We always, with rain fade, we always include in the calculations, well, what is the area that's operating in, and we use these rain regions. There's ITUR, there's also the crane models. but it's all based on the intensity of the rain. And so whereas in Seattle, it rains a bunch, it's not heavy rain, versus here in Dallas, it rains, when it does rain, it's more as heavier rain. So Seattle's a better rain region versus Dallas. So at the higher frequencies, you can actually go farther in Seattle versus here in Dallas. Finally, when we work with customers, we ask about availability. What's your availability? Is it 5 nines, which is about 5 minutes of annual outage per year, or is it, say, 4 nines, where you're at 4 nines is 525 minutes average outage per year. That's 52 minutes per average outage per year. So with the based on those your availability requirements, if you need a higher availability, well, that might increase your antenna size. It may require that you go to a lower throughput or lower modulation, or you go to lower frequency band. So again, it's all part of the consideration of what we need to do when we're planning it. What is your availability requirements? Do you need to keep outages to a minimum, or can you stand some outages because, say, you have a backup to the site? Site surveys, again, you guys probably do a lot of this already. You need to know, once we do this path analysis, when can you actually put it in? Can you get access on the tower to the proper height on that tower where the antenna needs to be placed? Where are you gonna install that indoor unit? How are you gonna run that coaxial cable or elliptical waveguide if it's all indoors, or the Ethernet cable if it's this all outdoor solution? So you need to see if, you need space available on the tower rooftop, and then some customers have to deal with a tower analysis or leasing tower space from a tower owner. So all those things you need to do as part of your planning. Once we say, yeah, you can do it, and then the next work is finding out, do you have all the logistics in place to do that for your hop? I want to talk about unlicensed versus licensed. So we offer licensed band solutions. There are a lot of unlicensed gear out there. A lot of it's 5.8 or 2.4 gigahertz. But the biggest issue with this is that it's you're not licensed. Everyone's got to work together to prevent interference. But there's no formal recourse if you do have issues, other than you working with the guy who's interfering with you. And we deal with customers that have had a lot of unlicensed links in place, and then they, come to us about how they always have issues. Or say, Monday morning when someone's connected up another unlicensed link, and now they're having to try to find a new channel that's available. So, with these unlicensed links, you're dealing with that random interference, and then when you're dealing with that, you're losing revenue in your day. Get that resolved. So those troubles, the spectrum analysis, finding interference, power climbs, that just can add up in cost. Again, the FCC license, it's you work with these frequency coordinators where they find a channel that's available for you that's non-interfering against existing users, and it's yours once you get it set in place for 10 years. And so at the cost, you're typically dealing with less than $1 a day in costs over those 10-year period for the link. So don't let the license process kind of sway you from, think it's going to be impossible to deal with the feds on that part. It's a very easy and straightforward process. And I keep saying that straightforward process. And there's a lot of license coordinators out there. There's ComSearch, there's Radine, there's Micronet, and most of them charge $2,500 per hop turnkey to do this for you. So it can be, again, very low cost for that license between the two hops. And many times, if you're doing 2 channels or 4 channels between the 2 hops, the cost per channel doesn't increase. It's just those 2 hops those 2 sites that you're licensing, that's your cost that you're paying for. So in the licensing, as I mentioned, you can do it. They check to make sure that this new link's not going to interfere with existing links. This license is 10 years. And the process, once you get started, usually takes 35 to 40 days. You can increase it improve it by 15 days because you can get the prior coordination notice, a PCN be done in 15 days as expedited option versus 30 days. But 40 days you can begin operation technically once you've started this process if you have the gear in place. Because once that license FCC application is filed, you can begin conditional operation until your license is formally received, which usually takes about 2 months. There's an exception at 23 gigahertz where these high power channels that are shared with the U.S. government, you have to wait till the actual license is filed before you can begin transmitting. There are 18 gigahertz quiet zones, and one of them's in the Baltimore area, so right in your backyard. So you can't use 18 gigahertz in the greater Baltimore, DC area. Once the link is turned up, the only last thing you have to do is you have to file this notice of completion with the FCC to say it was installed. You have 18 months from once the license is filed to turn up the link and get that notice of completion filed with the FCC. So you don't have to get it installed right away. So I include this for our friends up there in the DC area. This is the area of your exclusion zone. So in your greater area, you're limited to 6, 11, and 23 gigahertz. So keep that in mind as you're considering your licensed options.
Hello.
Yes.
Yes. You okay?
Hello.
No, I'm calling from my work phone that I have in the seat of the car. But we got something else going on my phone. The Washington SBE meeting while I'm coming home. I'm listening to it.
Okay. Okay.
Can you mute Alan?
Okay. Ooh,
Okay.
That sounds pretty good. Yeah. I like it.
Eric, I see you talking, but I think you're muted.
I am.
Okay.
I was just going to say, why don't you proceed?
Okay.
I think we've got that
All right.
taken care of.
Okay, I'll proceed. Okay, so the different frequency bands there is a requirement by the FCC for the antenna size that you use. This category A antennas, 6 gigahertz, it's the minimum size of 6 foot, 11 is 3, 18 is 2, and 23 is 1. And these all are based on the beam width and the gain of the antenna, and so that's what defines that minimum antenna size. But in recent years, they've relaxed the rules and they allow these category B antennas, which do have some caveats, whereas if these cause interference to users and decrease the number of channels that are available, they can make you change the antenna size, although I've never seen a customer have to change their antenna size once they've filed it under category B rules. But with them, especially at 6 gigahertz, you can use a 3 and 4 foot antenna size, and 11 gigahertz was a big improvement down to 2 foot as well too. So this can make the installations a lot easier, a lot less loading for you. So there are options with 6 gigahertz. Now, again, during the coordination with the comm searches of the world, that's where that will help be defined whether you can use those category A, have to use those category A's, or can go to category B antennas. So channel sizes. So again, as I mentioned earlier, the larger the channel size, the more throughput that you can get. Under the different frequency bands of 6 to 23 gigahertz, these are the channel sizes. 6 gigahertz, there are 30 and 60 megahertz channels available. 30 megahertz was the legacy size, and that's where the most channels are available, and 60 megahertz is fairly new. 11 gigahertz, now you can go up to 80 megahertz channel throughput, again with a larger channel, the more 681 megabits per second throughput. FCC does have usage requirements for these different channel sizes, so you have to be passing enough data so that you can use these channels. So you have to tell them, that I am going to be using, that you are going to be pushing a lot of data through, or the data that meets the requirements. And the rules differ based on the frequency bands of how many bits per hertz have to be used, whereas 1823 is 1 bit per hertz. So it's really easy to meet the requirements, whereas under 6 gigahertz, it's 4.4 bits per hertz that have to be used. So you have to meet a certain usage requirement to justify why you're using those larger channel sizes. And so 11 and 18 have our 80 megahertz channel plans where we can push a lot of data through. We can push additional data. This is all without using data compression. There are other techniques that we can use to push more data through just by compressing the data, taking out overhead, and then looking at ways we can decrease the, on the payload itself of the Ethernet frames. So what is the general cost for this Part 101 gear? Well, just looking at, say, 100 megabits throughput without the antennas, because the antenna size can vary based on how far you're going on your hop. So that's where it varies, but generally the indoor unit and outdoor unit are the same costs, based on the capacity. So a split mount, you're looking at $10,000 to $13,000, $10,000 to $13,000 for the gear, and then your installation cost is running, that coaxial cable and running that up the tower. All indoors, it's 18 to 21K for the gear, but you do have a higher installation cost. Again, that elliptical waveguide is much more expensive per foot versus coaxial cable, and then you need dehydrators to keep that elliptical waveguide free of moisture and pressurized. And then you need some space indoors for all that gear. Then all outdoors, generally the least cost, it's a little bit less than split mount these days. Again, it's all based on the capacity, but you're still running a cable up the tower, whether it's Ethernet cable or you're running fiber and 2-wire cable for separate power to it. But so that, all indoors is going to cost you more, but against maintenance wise, it's going to be better in the long term versus the split mount, which is lower installation costs. All outdoor, where all the equipment's up on the tower, that's going to give you your highest throughput. So what's the reliability? Well, the reliability of this gear has improved a lot over the last 15 years because now it's fairly all integrated. It's a digital board design, fewer connections, higher MTBF as results. There's no components to adjust. If you have an issue, have a failure, we're pulling out the ODU and replacing it, or pulling out the indoor unit and replacing it. When we're swapping out you're just pulling out the assembly and sending that to repair. There's nothing for you to try to change out in the unit. So it's important that you do have spares on hand to swap out the gear to make it easy, so that you can get returned to service quickly if an issue does occur. Again, as I mentioned, there's nothing to adjust. So you don't have annual maintenance associated with this gear where you did with the older indoor gear where you had to go in and make adjustments to those amplifier units. For the repair, it's just the entire units returned to us, and we repair the units for our customers. The biggest issues that we deal with on these split mount or all outdoor solutions is water ingress on the coaxial cables, or any connections that are outdoors. That's usually the biggest issue that we deal with customers, because that can affect the quality of the signal passing on that cable and result in noise, which results in lower throughput for the customers. We recommend surge arresters be used on coaxial cables or Ethernet connections to protect that gear against lightning strikes, because you're very dependent dependent upon how well that tower site is grounded. And so you need to protect yourself, and you should replace those surge arresters on a yearly basis. So most microwave gear supports Ethernet 2-layer functionality. So we have options where we can, we can operate as a switch out of our devices. We can do VLAN tagging, untagging, and some customers use this where they have everything tagged until it comes out of our gear, and then we untag it for them. So that can reduce some of the costs at the site where you're not having to put in a separate switch there at the site. We can prioritize packets. So we have a lot of the switch functionality that you find in standard switches. We have it available on our devices as well too. We can even define separate Ethernet tunnels across the radio link. So we can you have 2 connections to the indoor unit. You can say this unit it's 100 megabits per second throughput over the radio link, and this other one's 20 megabits, but this 20 megabits is high priority traffic, and you can define it as high priority. So for adaptive modulation, it's going to remain passing over the radio link as the modulation decreases, whereas 100 megabits, that'll be lower priority. You'll lose some of those packets, but again, your high priority traffic is prioritized over that radio link. We can support T1s still, so if you have those T1 legacy devices in your network, you can use the split mount products. And again, we're not the only ones. Other guys have it out there as well too. But the key thing is, I think, for anyone that has T1s, they're still on landline basis. I'm sure the costs per month are still going up and up. So this is an option to not only have T1, but Ethernet. And with our products, with the T1s, as you take out T1s, more capacity is made available for Ethernet traffic. And finally, for remote management, all of our devices you can manage remotely. You use a web GUI, and we support SNMP. So I don't know how you do management with your devices, but with SNMP, you can have traps sent to your trap manager to alert you when alarms occur, so that you're made aware of something going on. Our GUIs are very easy to use with your standard web browser and make it very easy to navigate and adjust settings, check what's going on. If you receive a trap, you can see, well, what's the reason for my issue. So with that, that's what I have on the licensed microwave gear. I hope I didn't take too long. Sale's going to talk real quick about Cielo Networks, and then we'll turn it over for questions.
Okay, thanks. Yeah, I only have a couple of slides, so this will be very quickly go through this. But I know we talked to you 3 years ago. We're operated out of Dallas, South Lake, Texas area, Dallas, Fort Worth. We're now based in San Diego, California, and talk about that shortly. 20 plus years experience in the microwave business, and of course, millimeter wave as well. And we have diversified quite a bit, to the point where we're doing a lot of public safety networks with at the state and local level, and then we do a lot of federal government work as well. And we've got customers all over, I think, in every state in the United States, and then internationally as well. We do a lot of stuff for some 3-letter agencies overseas, and that helps us out, but then also the trading networks. Everything we have is certified with the NTIA as well as FCC here in the States. And if you've seen with Brian talked about what we do with path analysis and engineering studies, we just don't deliver the equipment. We actually do a lot of customer support by helping them put a whole network together. And we can be glad to give you references. We've got plenty of people that have our equipment. We've got, I don't know, what, 7,000 or 8,000 microwave links we've installed in the last 16 or 17 years. Brian? Next one. We started out just as an E-rate, the kindergarten through 12th grade school systems in those days, early on in early 2000s. There wasn't much fiber, and every school had to have increased bandwidth, so that's how we got started. And again, that put us in about 40-something states. And then we got into the business-to-business market, and then diversified there into the federal, state, and local governments. And we do have certifications that allow us to get on a lot of the DoD installations. And we are in telcos, and we have international carriers, and I guess the largest telephone carrier we have right now is a customer, CenturyLink. And then Brian has spent a lot of time in the low latency market with the high frequency trading business. Those guys have done very well here in the last several months with the volatility of the stock market, and we still maintain a lion's share market share. And we got a couple of products that Brian showed throughout here. One, we have the split mount option. We call it the CG2X. And several of you that are online have bought that product. And it's a very reliable product. We continue to give upgrades to it, and it's got a good future. And then the one that Brian talked about at the end, the all outdoor solution, we have a single transceiver and a dual transceiver. As you can see, the capacity up to 1.2 gigs on the single transceiver, and the dual transceiver 2.4. And we have started to deploy quite a bit of those since the bandwidth has increased. And last, on our end, if you have any questions, you can contact me at that address, email address. And Brian is still in Dallas area, and I'm in about an hour southeast of Memphis, Tennessee. And the new owner that lives out of San Diego, California. That's why we have our corporate headquarters there.
Yeah, and I'll provide a soft copy of this presentation for you guys to have available to download.
We do appreciate the time that you gave us. We really do. Eric, back to you.
Yeah, we thank you for joining us. And I guess what we might want to do for just questions, I can just unmute everyone. That might be a terrible idea, but let's try that and see if we get into trouble. So did anybody have any questions?
Curious what your competition thoughts, competitive thoughts are with regards to something like Ubiquity Networks. For it's clearly a different use case, but I'm seeing a lot of that come up with solution for point-to-point type building connection. Just curious what your how would you?
Yeah, Ubiquity has that that lower cost type of solution, which isn't as say carrier I always say carrier quality. It's almost one-time use type product. So sometimes the reliability of that product isn't as good. We do see it as competition, but not necessarily at the say 6 gigahertz bands. And I think where are they primarily at nowadays, Sale? Do you remember?
I think they do a lot of
11 gigahertz is where they have that integrated solution. So we have a lot more flexibility, and we have the ability to support higher throughputs with our higher modulation techniques. So it's all a matter of, again, how much money you want to spend and what type of quality product that you want, as well as, product support as well too. I don't know how well their product support is compared to others. That's something that's very important to Cielo Networks, and what we provide our customers is not just pushing boxes, but also making sure that, it's a full turnkey where we're not necessarily installing the equipment, but we're providing that path engineering support on the front end, and then the support during the installation, and then the support long time after the product is sold.
I think the other thing that we see is with Ubiquity and maybe Mimosa, the ISPs, we lose a lot when it comes to competing apples to apples with them. But you get into the public safety networks, I could not give you a customer that has bought Ubiquity or Mimosa for a public safety network. They want the reliability, and they'll pay for it. But then you got people's lives in danger there, as opposed to somebody not being able to watch Netflix tonight. Everybody's getting tired, huh? At the end of the night.
It has been a long day. I expected a little more questioning. I noticed you mentioned that CBS Radio had an issue. Is that the site over by the ballpark in Washington?
Yeah, the intercom site now.
Okay, right, of course.
Eric, I helped install that link, so if you've got a question or two, I might still be able to answer it.
I was just wondering how they sorted out all the construction, if they had to put in a second hop or if there was some relocation that would work.
That was exactly what was done. It used to be a single shot from the roof of 1015 Half Street out to the WPGC transmitter, where everything then broke out on 950. And with the construction of the new condominium building down there, no surprise, that path got blocked. So to get around that problem, we did a hop at, I believe it was at 23, across the street to, I believe it's the Lerner building, where we turned it around onto an 11 gig and just shot, and the shot goes straight down M Street Southeast and out to WPGC. It's just a little equipment shelter up on the roof, 2 dishes, 120 amp circuit, worked like a charm.
Yeah, it seems like that's always the challenge with line of sight. I remember when I first came to Washington a million years ago, and you drive down Connecticut Avenue, and I think it was, what was it, MZQ was in that little short building, and there was a dish that pointed up to the top of the apartment building across the street and then out. So as long as all you need is electricity and line of sight, you can usually find a place. I guess the only other question I was going to ask Brian is for the versions that have power up on the tower. Does anybody bother to try and put in uninterruptible power or batteries or anything to hold those links up for brief outages?
Yeah,
or is it not really practical?
No, yeah, it's the power is still down at at your enclosure. With a split mount system, the power is run up the coaxial cable. If even for the all outdoor solution, your PoE device is usually on the base of the tower or connected to the side, the wall of your building that's right there, and where the Ethernet's connected, or you have it indoors, but you're plugging power into it. We have AC and DC versions, so you can plug it into the wall or plug it into your DC power supply. And a lot of customers using the DC version if they have the battery backup solution there. But we have plenty of customers with that, the battery type backup solution, but those are all still indoors in the system, and then you run power up the cable up to the unit.
Does anyone else have questions for our guests? Well, if not, I'm going to thank everybody for coming.